Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from Google Agent Quality. We're entering an era where AI agents don't just answer questions, they reason, plan, and take actions on our behalf. It's easy to build a flashy demo, but running these systems safely in production is a very different challenge. This white paper argues that the real differentiator isn't just model capability, it's how rigorously and continuously we evaluate and improve these agents. That's what turns a clever prototype into a system an enterprise can actually trust. Agent behavior is inherently non-deterministic. The same prompt can yield different answers, and behavior shifts as models, tools, and data change. Traditional software quality assumes fixed logic and repeatable outputs, so old QA methods break down. This paper frames agent quality as a new discipline that must handle probabilistic reasoning, safety risks, and ongoing behavioral drift, not just static correctness. A framework centers on four concrete pillars of quality. First, effectiveness. Does the agent actually solve the user's problem? Second, cost efficiency. Are we getting that performance at a sustainable compute and operations cost? Third, safety. Does the agent avoid harmful, biased, or policy-violating behavior? And finally, user trust. Do real users feel comfortable relying on it? These aren't abstract ideals. They're the targets that all evaluation work should be aligned to. A core message of the paper is that evaluation can't be bolted on at the end. The authors use a race car analogy. You don't build a Formula One car and then remember to add sensors. You design it with telemetry in mind from the first sketch. In the same way, serious agent systems must be evaluatable by design. Logging, tracing, and feedback hooks are part of the architecture itself. Quality becomes a design decision, not a final QA phase. To evaluate an agent, you first need to see what it's actually doing. The paper emphasizes observability as a foundational practice. Structured logs capture each step of the agent's reasoning and actions, its diary. Traces then stitch these steps together into an end-to-end narrative for a single task or user session. With this level of visibility, you can finally inspect how the agent arrived at an answer, not just the answer itself. For agents, the final answer is just the last sentence of a long story. The paper argues that the true signal lies in the trajectory, the full chain of thoughts, tool calls, and decisions that led there. Process evaluation focuses on this path. Was the reasoning sound, safe, and efficient? Did the agent follow the right tools and policies? With deep observability, you can analyze trajectories to understand not just whether the agent got it right, but why. The paper positions evaluation as a hybrid engine. On one side, LLM as a judge systems can rapidly score outputs and trajectories at scale, giving you broad coverage. On the other, human-in-the-loop evaluation provides the gold standard for nuanced quality, safety, and fairness. Automation helps grade the test, but humans still write the rubric and decide what an A+ really means. Together, they create a practical, scalable evaluation pipeline. All of these ideas come together in what the authors call the agent quality flywheel. Imagine a heavy flywheel that's hard to start, but easier to keep spinning once it's moving. Each evaluation cycle is another push that builds momentum. Over time, the system becomes self-improving. Every failure, every edge case, and every user interaction feeds back into better tests, better models, and more trustworthy behavior. This flywheel is the operational heart of the framework. The first step in spinning the flywheel is to define what quality actually means for your use case. That means turning the four pillars, effectiveness, cost efficiency, safety, and user trust, into explicit metrics and thresholds. You connect each pillar to concrete business value and risk, and you make trade-offs visible. For example, you might accept slightly higher cost for a safety-critical workflow, but not for a low-risk internal tool. Once you know what you care about, you instrument the system so you can actually measure it. Agents are built to emit structured logs for every key step, and traces that link those steps into full task narratives. You capture prompts, intermediate thoughts, tool invocations, and final outputs. This observability data becomes the raw material for evaluating effectiveness, cost, safety, and trust in a systematic way. With visibility in place, you can now evaluate. The paper recommends an outside-in approach. You judge not only the final outputs, but also the underlying trajectories. Automated LLM judges give you broad, fast coverage across many scenarios, while human reviewers focus on complex, high-risk, or ambiguous cases. This dual view lets you catch subtle reasoning flaws, safety issues, and inefficiencies that would be invisible from outputs alone. The final step is where the flywheel gains real momentum. Every production failure or near miss is captured, annotated, and turned into a permanent regression test in a golden evaluation set. Over time, this set grows to reflect your real-world edge cases and risks. When you update models, prompts, or tools, you rerun the golden set to ensure you haven't reintroduced old bugs. In this way, every incident becomes a learning opportunity, not just a one-off fire drill. The first core principle is to treat evaluation as an architectural pillar. You don't wait until launch to ask how you'll measure quality. Instead, you design the agent, its tools, and its infrastructure around measurement from day one. Telemetry, logs, traces, and evaluation hooks becomes as important as which model you pick. This mindset shift turns quality from something you inspect at the end into something you engineer throughout. The second principle is that the trajectory is the truth. A seemingly correct answer can hide unsafe shortcuts, hallucinated tools, or policy violations along the way. By inspecting trajectories, you see how the agent actually thinks and acts. This process evaluation becomes a powerful lens for both safety and quality, letting you catch issues that would never show up if you only scored final outputs. The third principle is that humans remain the ultimate arbiters of quality. Automated judges and safety classifiers are essential for scale, but they operate within boundaries set by people. Humans define what counts as a good answer, what risks are acceptable, and what fairness and safety look like in context. Especially for high-stakes systems, human-in-the-loop evaluation is not optional. It's how we anchor the entire stack to real human values. The paper closes with a clear warning and an opportunity. Agentic AI, systems that can reason, plan, and act, will likely reshape how organizations operate. But without a rigorous, integrated approach to evaluation, many teams will get stuck in a loop of impressive demos and failed deployments. Those who invest in evaluation engineering as a core capability will be the ones who move beyond the hype and deploy agents that are not just powerful, but reliably so. Ultimately, the goal isn't just to build agents that work some of the time. It's to build agents that people and organizations can trust. That trust doesn't come from optimism or marketing. It's forged through continuous, comprehensive, and architecturally sound evaluation. With the agent quality flywheel in place, every interaction and every failure becomes fuel for improvement. Reliable agents aren't an accident. They're the result of this disciplined, ongoing practice.